Guys, welcome back. In this video I'm going to basically talk about the restrictions for the sine function or trig functions, especially the sine, cosine and the tangent, and also the inverse, so that we can figure out what are the restrictions and what are the values that the sine inverse or cosine inverse or tangent inverse can have and cannot have. Okay, so guys, I would suggest watching my previous video so you can understand, like, there's a link between that one and this one. I have already kind of explained the idea of this inverse trig functions, which is basically the inverse process of the original trig function. So in the original trig function section, guys, we usually try to evaluate or find the value of the sine of a given angle, but with the inverse trig functions, we are basically, in simple terms, we are now going backwards. The inverse process is like finding the particular value for that angle for which the sine or cosine or any of the trig functions have a particular value. Okay, so keeping that in mind, now guys, we are trying to look at the more technical details about the restrictions for sine and cosine and tangent functions. So guys, let us quickly recall, and that is something I expect you to already know, but I'm quickly going to recall those basic things. Guys, we have a sine function, sine of theta. We know sine of theta looks like something like this, right? And that's something, guys, I'm expecting you to know. So from the graph and from the basic understanding of the sine function, guys, we already know that the domain for this function, and we can see it from the graph as well, it just goes on forever, left and right. So domain is negative infinity to positive infinity. And then we are also interested in looking at the range, and we know that it does not go anywhere above positive 1 and down, like in the negative direction it goes only up to negative 1. It touches both of those points. That's why we say that the range is between negative 1 and positive 1. Square brackets obviously tell me that it can touch those points. It can touch the endpoints, right? This is something we already know, guys. Same thing for the cosine, and then we also know what is the domain and range for the tangent functions. Guys, at the end, I'm going to write all those here on the side when we start actually looking at actual examples. Here, I just want to illustrate this concept of the inverse and the regular sine trig function for the sine, and then for the rest, I'm just going to write the basic domain and range, okay? Guys, this is the domain and range for the sine function. Actually, for the cosine function, it's the exact same. But here I want to now I want to talk about the inverse of this function. Guys, you have to go back and recall the fact that in order to write the inverse of any given function, that function has to pass the horizontal line test. Okay, that comes from the idea of the algebra. Guys, but if I look at this particular function, if I try to draw a horizontal line, what I will see is that the horizontal line passes through several points. So it basically fails the horizontal line test. I mean, let us think about this horizontal line going like this. Okay, keep in mind, when we draw any horizontal line, we also keep in mind that it is not just a fixed line. It is something that can move up and down. So I mean, it touches at so many points, so it fails the horizontal line test. Now, if this guy fails the horizontal line test, that means we cannot we cannot write the inverse of this function, okay? So if we cannot write the inverse of this function, then there's like, why are we even talking about the inverse trig function? That means we cannot have inverse trig functions. Guys, that is almost correct, but we can do something with the sine function so that it passes the horizontal line test, and then we will be able to find the inverse of that function, because all it has to do is it has to pass the vertical line test. Now, by itself, this whole thing, it does not pass the horizontal line test, so we may not be able to get the inverse of this whole function. But guys, keep in mind, if I restrict, so this point right here, the coordinates are, I have pi over 2 angle, and here I have negative pi over 2, okay? Guys, I don't have a graph paper here, so I cannot like draw these things accurately, but if you like, you can look at your textbooks. Once you go over this explanation here, then you can look at your textbooks carefully, and you should also read through the explanation in your textbooks, and it will be more clear to you. So guys, if we restrict this whole domain from here to here, so let me just analyze that much. Let me just analyze, or let me just redraw just that piece. So that piece is going to look like this. I'm stopping right here, and guys, this is my pi over 2, and this is negative pi over 2 on the x-axis, and of course the y-axis is still between negative 1 and positive 1. Now guys, if I restrict this, if I ignore anything to the right of pi over 2 and everything to the left of pi, negative pi over 2. Then if I restrict it only to this, now does this pass the horizontal line test? Yeah, if we try to draw a horizontal line, it's only going to cross or touch at one point. So it does satisfy the condition of horizontal line test. It passes the horizontal line test. Now if this guy passes the horizontal line test, this is still a sine function. It's only a piece. It's only a part of the sine function, but it's still a sine function. So we should be able to get the inverse of this function, and the inverse of this function, which kind of looks like, guys, here it may look almost like this, but if you look in your textbooks carefully, it is slightly different, because we know to get the inverse is basically reflecting the given function with respect to the line y equals to x. And here I'm not going into all that transformation and reflecting details, but that is basically how we, if we are actually trying to draw this whole thing, or you can actually use a graphing calculator to draw it and you will see the same thing. Guys, this is going to look something a little bit like this. That is what the inverse is going to be. Guys, this is the inverse function. Now this is my sine theta. Yes, it is restricted between negative pi over 2 to pi over 2. So if I just focus on this guy, the domain is negative pi over 2 to positive pi over 2, and my range is still going to be the same, negative 1 to positive 1. Now guys, if I look at this inverse function, now this is my inverse function, sine inverse of theta. Okay, and guys, here this is between negative 1 to 1. We know that from our pre-calc and from our functions section on functions, that these kinds of these switch, and that is how we basically evaluate the inverse of any function. The x's, the input and output, gets switched. So when input and output switches, that means the domain becomes the range and range becomes the domain. Guys, you may have to review those things from your pre-calc, but if you don't want to do that, guys, still I'm going to make sense out of this. We have to kind of just understand some basic things, and then we got to use those to evaluate the inverse of different trig functions. So it's from negative 1 to 1. So the range becomes the domain and the domain becomes the range. So this here, it is from negative pi over 2 to positive pi over 2. Okay, that is basically what happens when you go from a function to its inverse. Guys, you can check this in your textbooks, or you can use a graphing calculator and see the exact shape of what a sine inverse function. Okay, now the domain for this guy is, again, you can see it is negative 1 to positive 1. Right, it's the domain has to do with the x values, the left hand and the right hand, and the range, guys, is negative pi over 2 to positive pi over 2. Guys, this is something that one has to keep in mind, or one has to remember when we are dealing with inverse trig functions, and basically once we start using them to solve trig equations. So that is something that one has to remember, one has to keep in mind. Guys, for me personally, I don't try to remember this or memorize this. What I know is, I know my sine function. I know my basic idea of I only have to work with this, just this piece of the sine function. Once I work with that piece, I know my domain and the range, and when I take the inverse, I also know the basic fact that the range and the domain are just get reversed when we take the inverse. So range becomes the domain and domain becomes the range. And that's how I like to make the connection, and I remember this stuff, okay? Guys, the other easier way sometimes people use to remember this is they like to draw the circle. So, I mean, it's up to you if you want to kind of use that. So guys, they draw the circle. You can think of this as a unit circle. We already have been using the unit circle to evaluate the trig functions. So guys, the domain we know is restricted between negative 1 to 1, right? Negative 1 to 1. But then the range, which is going to be the most important thing when we evaluate the trig functions, guys, it is between negative pi over 2. We know this is negative pi over 2 because it's like below the x-axis, and then here it is positive pi over 2. So they only, I'm highlighting this, so that tells me that's another way of remembering that the range is for the sine inverse function is between negative pi over 2 to pi over 2, and the domain is between negative 1 to positive 1. Guys, this is one of the ways that people like to remember the domain and the range for the sine inverse function. Similarly, guys, we can do the same thing for the cosine function. Of course, the graph is going to be slightly different. It is a little bit shifted, right? And then we can we still have to restrict it because it does not pass, the whole graph does not pass the horizontal line test. So we only have to take a small piece out of that whole graph. Then we take the inverse. Again, we will have a domain and the range. Same thing, guys, we can do for the tangent function, the cosecant function, and the other functions. Here, guys, the most important functions are going to be the sine inverse, the cosine inverse, and the tangent inverse. So I'm going to write the domain and range for all three of them. We already know, like we already saw how to actually evaluate or how to get the domain and range for the sine and its inverse, sine inverse. For the rest, I'm just going to write them as a rule, and we're then going to use them to find or evaluate the inverse functions, inverse trig functions. Guys, there's one more thing that I want to say before I move on to the next video where I bring all the sine, cosine, and inverse functions. Guys, here, look at this graph. One also has to verify that it is a function. It's a graph of a function. And guys, if you look at this graph, you can clearly see that it passes the vertical line test. If I draw a vertical line, it is only going to touch it at one point. So guys, we also have to make sure that this is a function, because we have been saying inverse trig functions, but function has to satisfy the vertical line test. So it satisfies the vertical line test. Guys, this guy also satisfies the vertical line test, but keep in mind, these are two separate things. There's a vertical line test which tells me whether the given relationship or given graph is a function or not. So for that, we need to use a vertical line test. But to see whether what function we can find the inverse of a function, one has to use the horizontal line test. So guys, these are two separate tests. This does not pass the horizontal line test. That's why we only take just a chunk of this or just a piece of it. Once we have this piece, it satisfies both the horizontal line test and the vertical line test, and then we're able to get the inverse. So guys, this is the basic idea of getting the inverse of the sine functions. Here I illustrated the sine. We can do the same thing for other functions. Guys, I will see you in the next video with some examples. Till then, take care.